Welcome to Found in Space, a science podcast for kids and teens. We have such a great question today. Our question is, how far up do you have to go before gravity stops? And wow, this is a fun one to talk about because you know what? It's actually an illusion. Gravity never stops. There is gravity everywhere. Everywhere has gravity, and gravity is really, really important. In fact, we've talked a lot about gravity on this podcast. And today we'll talk about some of the reasons why gravity is so important. But let's start with, well, what is it? Well, gravity is the force, or the apparent force, that seems to pull everything together that has mass. So having mass means that you're made of stuff, right? If you look at your own hands, you're stuff, right? You have mass. Other things have mass too, like stars, they're made of stuff. And mass doesn't have to be visible to us either. Air, for example, air is stuff, so it's mass as well. So anything that's got mass is being pulled together by gravity. But the more mass, the stronger it's going to be. And little things like us, we don't really notice that there's gravity pulling us together because we're right next to something way, way more massive, right? We're standing on Earth. So we notice our gravitational attraction. We notice ourselves falling towards Earth, even though we don't really notice ourselves falling towards each other because it's only a tiny, tiny bit. And here's another rule about gravity. The closer the two things are to each other, the stronger, the more intense that pull of gravity is going to be. That's why when we jump, I bet you could jump right now. Did you try it? If you can, right? If you're strapped into a seatbelt or it's not safe for you to sit up right now, don't try it. But if you do, you're going to fall right back to Earth, right? Now, Jupiter is a lot more massive than the Earth is. But we don't fall towards Jupiter because we're right next to the Earth. So we feel Earth's gravity more than we feel Jupiter's. Now, gravity is something that we're all used to. It's always been here. As long as we've been alive, there's been gravity. But it wasn't until pretty recently that scientists started thinking about and studying gravity. And the most famous, the first of them that we have good record of, was Isaac Newton. Now, he's famous for a lot of things. One of the things he did was actually he invented calculus, which is this really fun type of math that we can use today to help us learn about and describe all sorts of things. But he also thought a lot about gravity. And he wrote down his observations, and he wrote one of the laws that we still use today to describe gravity. So a law in science is different than a law in everyday life. A law in everyday life might be something like you're not allowed to litter. You can't just throw trash on the ground. Now, you shouldn't throw trash on the ground. That's not good, right? But you could, theoretically, right? It would be possible to break that law. But a law in physics isn't something that you can break because the law is just a description of the way that the universe works. It just works that way. Now, if we find out that it doesn't work that way, it means the law was wrong. So we have to rewrite the law. So he didn't understand why gravity works the way it does. And you know what? We're still trying to figure that one out. We've gotten closer to it, but there's a lot more for us to learn still. But he described how objects behave when they're attracted to each other at what distances. Now, let's wait a while, and later along comes Albert Einstein. Now, Einstein really refined, he helped us understand gravity in a different way. With a Newtonian perspective, thinking about it the way Newton would have thought about it, we could think about gravity kind of like a string tied between two objects. But Einstein changed this perspective. And with what we call general relativity, he came up with this idea that basically space and time, we call that space-time, that they are warped. Their shape, the shape of space itself, changes when there's mass. So the more massive something is, the more it's going to warp space-time. And it's not just how massive it is, but how much can we fit in a space at a time? So how dense is it? And so this is where you might have seen pictures of this before. If you've seen space drawn like a big grid or like a sheet of rubber, I like to think of it like the cushions on a couch. And then you put something massive in it, like a big ball, maybe a star, or here on Earth, you could imagine putting a bowling ball on top of your couch. And so when that happens, the sheet of rubber or the grid, the couch cushion, it curves a little bit. It makes a little indentation. And that curve is what we think of as gravity. The steeper the curve is, the stronger the gravity is. Now, everything, we all make those little dimples, those little depressions or little craters in space-time. But small things like us, we don't make as big a curve as something like a whole star or planet does. So, gravity is actually what's responsible for pulling the material together to make things like stars and planets in the first place. And so if you have a little curve, with maybe you have something about the size of an asteroid, but it's making a little curve or dent in space-time, and so another object might fall down that curve, and then the two bump into each other. And now that curve, that little hole in space-time gets bigger and bigger. And the bigger and bigger it gets, the steeper and steeper it is, the more and more things start to fall in and be attracted to it until they grow bigger and bigger and bigger and bigger. And we get things like Earth or the sun, or even things like black holes, which we've done a few episodes on before here on the podcast. We should definitely do some more black hole topics soon. Okay, so space has gravity everywhere. The farther away you get from the mass, the weaker and weaker the gravity becomes, but it never disappears. So let's go back to this idea, because we've all seen the videos of astronauts floating around in space, right? It looks like there's no gravity. So what's going on? As I said before, it's actually an illusion. There is gravity. So what's happening is that the astronauts are in orbit. Now, orbit is another way for us to say falling around. So I want you to imagine a rocket blasting up into space. It's going up, 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 up. Now, it's being pulled on by gravity, but it's blasting up. So it has enough thrust, it's pushing up enough that it can fight that gravity. It's like when we jump, that moment that we jump, we're jumping and fighting gravity. But we only have just one little boost to get us up, right? But if we could somehow keep jumping and jumping and jumping, that's what a rocket is doing. Well, eventually, that rocket is going to get all the way out into space. And what we're going to call space here is where we get out of the air. There's not very much air left. It's out of the atmosphere. Gravity's going to pull that rocket back down. So what the rocket does to not fall back down is it tips over on its side. And then it starts going away from Earth, or away from whatever it's orbiting around. It's going horizontally now, so side to side instead of just up and down. Now gravity's going to pull it down, but if it goes fast enough forward, by the time it gets pulled down, the Earth won't be underneath it anymore. So it just starts to fall around the planet, as long as they keep going forward, right? So astronauts are actually in free fall towards the Earth. That's why their hair is floating all around, and if you see they're wearing a necklace, or it's really fun if you see them eating or drinking and there's a drop of water and the water's just floating around like a little ball, it's because all of them are falling towards the Earth. Now, everything that's orbiting is doing that. So the Earth is actually falling towards the sun, but we're going sideways fast enough that we always miss hitting the sun. And that's what the moon is doing around Earth, or any of our satellites that are going around different planets. We're just falling around in a very, very controlled way. So, to come back to the answer for this question for this episode is the gravity never stops. It's always there, but it can look like it stops if you start falling around the planet, if you go into orbit. Okay, friends, this was another really fun one. So I hope that you all have dark skies. And if you have any questions you'd like us to talk about on the podcast, please go ahead, have your folks send it to the email in the description box. And of course, remember, stay curious.